The facts are our antibiotics that we have are now becoming useless in treating infectious diseases. If we don't do something, by 2025, more people will die from infectious diseases than from cancer.
Throughout history, infectious diseases have been some of our worst adversaries. And although there have been great strides in prevention and treatment, infectious diseases evolve quickly. Recently, the Zika virus, which is transmitted through mosquito bites, made headlines after it traveled halfway across the globe and landed on American shores.
I think we are on the verge of an epidemic. I believe it's a matter of when. There's some talk about small outbreaks of Zika. There's no such thing as a small outbreak of a humanitarian tragedy.
Whoa, that's the yellow fever mosquito, the mosquito that carries Zika right there.
Scientists are doing their best to develop preventative measures. Some researchers are going to the ends of the earth to stop these potential pandemics.
We realize that the ocean is a massive biomedical resource, a new source for drugs.
I mean, Zika virus is causing all this harm because people are getting it, they don't have any immunity, and it's causing harm to their babies. This whole effect of microcephaly, which is what we're seeing linked to Zika virus infection, it could be happening just because it's the first wave of adults who are not immune getting infected. And now we're finding that Zika virus can spread sexually, directly from one infected person to another person. Scientists believe that mosquito transmission is probably the main way it is spreading. We had Zika virus since the 1940s, possibly before that. It was mostly in the equatorial forests of Asia and Africa, and it didn't really infect people that much because it was carried by a forest mosquito that didn't really like to bite people. It mostly bit animals. So first it spread out of Asia into Micronesia and Polynesia, and from there it hopped on a flight and took root in Brazil. And in Brazil, it's carried by a totally different kind of mosquito, Aedes aegypti. Unlike the forest mosquitoes, it bites humans. And this mosquito can breed in a drop of water in a bottle cap. All of our garbage around our homes and in our urban areas is perfect. Just a little bit of water in those things, and this mosquito can start to reproduce. So this is a huge reason why Zika is exploding so rapidly right now across the Americas. And so it's exploiting, our flight network, and it's exploiting our urbanization. And this is going to continue because, of course, we're becoming an urban species. By 2030, the majority of humans are going to live in cities.
There's plenty of mosquitoes here. They've been with us in existence before we came in, over 100 million years. It's amazing how they were able to survive after mankind has thrown so many chemicals at them. If the mosquito that carries the Zika virus is flying around and happens to get blood meal from that person who's stepping from the airport who has a Zika virus, then we will have a local transmission because now our mosquitoes here will pick up the virus and will start the cycle, and we don't want that. We're going to one of the 268 trap sites we have in the Harris County. To attract mosquitoes, we use dry ice, which simulates carbon dioxide from a human being. This site I'm going to take you to we call it a storm sewer site, where we have a trap in a sewer system. See the trap is down there? Let's see if there's any mosquitoes in there. Look at that. See? These are the Culex mosquitoes that we go after for the West Nile virus. And these mosquitoes we'll take to the lab. The virology lab will do a test to see if this mosquito has St. Louis encephalitis, West Nile virus, and so forth. And if the mosquitoes here, we find they have West Nile virus, then we know we gotta come to this area and spray or do something.
What we do here at Harris County Mosquito Control is a first line of defense for detecting mosquito-borne diseases. Today, we're actually gonna test these particular mosquitoes for dengue. We also send out samples for Zika testing. We are working with the female gender because many people don't know the female mosquito is actually the gender that bites. When we look at a plate like this one and I don't see anything developing, it's a sigh of relief for us. All is clear, which means this morning we don't have dengue. And so we're happy about that.
All right, ready to go again? You ready? You racked up? Okay, sir. In 3, 2.
Could you be raising mosquitoes in and around your home? Once a week, empty or remove items that can hold water, such as tires, buckets, planters, kiddie swimming pools, gutters, and bird baths. Prevent the bites day and night. It's called source reduction, where we educate homeowners about containers or removal of tires, eliminating the breeding habitats of mosquitoes. There's never an end to the fight because that's really nature.
With all of our methods and our tools, we can bring it down, suppress mosquito populations to a really low level. But it's like sitting on a spring. As long as our tools are working, we keep it down. But eventually, resistance sets in. And so then the tools stop working. So then it's like you get up and the spring comes right back up. So mosquitoes have been called winged bioweapons. They've been called agents of bioterror. And the thing that's so ironic about that, of course, people don't consider them terrifying. That's the whole problem.
This is a humanitarian catastrophe that's unfolding in front of our eyes, and I really don't see any significant global action right now.
I testified before Congress because I think we've not really gotten the word out there about how vulnerable the Gulf Coast of the United States is to Zika. I hate to be so dramatic, but this is the virus from hell that's stopping the development of the fetal brain. If we start seeing Zika cases, it'll be talked about in the same context as other Gulf Coast disasters, as the BP oil spill, as Hurricane Katrina. We have here in Houston the poverty and the Aedes aegypti mosquito that make it possible to see transmission of Zika. I've seen this in the poorest parts of Brazil, and I believe the same factors are in play here on the Gulf Coast. This is real Gulf Coast southern poverty. Look at our left here. What you'll see is an absence of gutters. And so without the gutters, you just have this water after a rainstorm like we had this morning that came through. And then next to that, you have houses like we have on the right over here, where there's no window screens. Mosquitoes can easily get into the house. All of these factors create the perfect storm to allow mosquito larvae to breed. The mosquito transmits diseases that cause an estimated 700,000 deaths annually. So a lot of that is from malaria, but it also includes dengue, it includes Japanese encephalitis, and it also will include Zika.
We're in the business of controlling mosquitoes that spread disease. We created our first Oxitec product, which we call OX513A, in 2002. The mosquito is the world's most dangerous animal when it comes to humans. So the mosquito kills more humans every year than humans do in wars. There is no Zika vaccine. We won't have a vaccine for years. We don't have years. This is an emergency. To control this virus, you have to control the vector, which is where we come in. OX513A is a strain of mosquito. What we've done is we've taken Aedes aegypti. We've then inserted 2 genes. The first gene is what we call a self-limiting gene. That self-limiting gene is inherited by all the offspring. We send out a male into the environment. The male will do what males do best, which is find females and mate with them. And then all the offspring will inherit a copy of this gene, and then they will die. But by doing that in a very controlled way, you're actually reducing the population. The other gene is what we call a fluorescent marker. So basically it's a color. You have like a sort of track and trace capability, so you can see the effect you're having. You can kill a mosquito with insecticides in the same way as that I can use my hand and I can kill a mosquito. But you can't control a population of mosquitoes all around the town living dispersed. Whereas with our system we can, because we're using the male to find the female, which is always going to be much more successful than using a human operator with a bag of chemicals on their back trying to find every insect. We've done field studies in Cayman, several in Brazil and in Panama, and what we've seen in every single case is where we're actually using our mosquito, we've reduced the population of insects by over 90%. With less mosquitoes, less disease. Very straightforward. So now we're going into our mosquito development room. This is our mosquito factory. These are mosquito eggs from Aedes aegypti. Now you've got several million here. So actually in this little building here that you can see, we can produce about 20 million eggs a week. And you could ship these anywhere in the world. So we're going to go down and look at some fluorescence. If you look at the larvae, if the male parent has been an ox-tech mosquito, then they show up red. If it's a wild mosquito that's the parent, it's grey or brown colour. So what we're looking at is a couple of larvae here under a white light, so you can see both of them. Whereas when we look at them under a filter, you can only see one. So imagine we were doing this in very large scale, we'd say 50% of the larvae were mated by an ox-tech male. So it's a very effective monitoring tool. Well, actually, we know a lot more about genetically engineered mosquitoes than pretty much anything else. I mean, we have gone through 150 or more generations of our product. The science, I think, is not the main issue because it's excellent and has passed every test. The issue, I think, is more public perception of genetic engineering. When you think about genetic engineering, your thoughts are often coming from GM crops. And what you do with a GM crop is you're actually giving the crop some kind of advantage. You make a genetic change and it stays in the environment. What we're doing is the exact opposite.
In the public eye, the genetic engineering modified mosquitoes is stigmatized, yes. However, the FDA has just approved a technique with Oxitec, and they're coming to the United States now, and they might be using it soon. Wouldn't that be better just to use a mosquito against mosquito, and instead of damaging the environment with a lot of pesticides? For me, that's better.
The local mosquito control teams, if they like using larvicides or adulticides, then by all means carry on. But use our system in combination, because then you're using both chemistry and biology, and we'll beat this mosquito.
Our battle with pathogens has really only just begun, because we've only been able to see them for like 100 years. The question is, how do you get from the period of time when you have no immunity to the period of time when you have the immunity? You have to pass through a whole process of death and sickness before you get to it. So that's the costliness of our best defense, which is our own immune system.
While studies in Texas remain focused on prevention of infectious diseases like the Zika virus, a researcher in Southern California has his attention set on new ways to fight viruses once they've been contracted. He's fishing the oceans as an unexplored source of antibiotics.
So, what's happening out there? People go to the hospital to have their appendix taken out, and they end up with a MRSA infection. It's over 90% resistant to antibiotics. We're going to get an epidemic of infectious diseases in the next 5 years. This is a serious problem that we are not properly addressing in the United States. And so we realized that the ocean is a massive biomedical resource, a new source for drugs. In 1973, I came down to Scripps Oceanography, and I knocked on the door, and I said, I want to develop chemical studies of life in the sea. I want to do some things that people have not done. In the beginning, we were just exploring. Belize, Central America, Palau in the Indo-Pacific, Guam. I do have stories about being on board ships when we were serious danger. From hurricanes, serious weather conditions. We've also been attacked by pirates, in which the captain had to actually fire a weapon at them. What we've tried to do is explore, because we didn't know where the most exciting microorganisms were found in the ocean. We looked at seawater, we then went to the bottom sediments, and we began to understand what's there. But then we realized that bacteria were inside different plants and animals. We needed to develop sampling strategies to collect samples beginning at 1,000 meters, 3,000 feet. So we've developed simple tools like this device, which I would call a snapper. We'll drop this from a boat. When you hit the bottom, the jaws close. You bring it up to the surface, and you've got a nice sample of material to work with. We have about 18,000 strains of bacteria that we've isolated over the past 15 years. We put them into cryopreservation. In each box are small tubes, one strain of bacteria. We can then remove and begin to unravel the complexity of what's in that particular compound.
These are environmental substances. They've been around for millennia. In the last 90 years, we've harnessed them and administered them in large scale to patients. We're just unmasking them slowly and slowly. And the more antibiotics we use, you're then allowing the environment for these antibiotic resistance to bacteria to become more and more prevalent. Then it starts off like this vicious cycle, longer hospital stays and higher medical costs. Good morning. A little nauseated? Okay. So we have a plan for your antibiotics. The one for the more serious infection, the staph infection, you'll get that for 6 more weeks. At least get it down. And then once we get that infection down, then you can go in and have your surgery. The only way you can stay ahead of this constant evolution is by developing more drugs. Patients get side effects to antibiotics all the time. And if a patient gets a life-threatening adverse reaction to your one antibiotic left, then you're back to no antibiotics. And the consequences of obviously increasing risk of dying from getting these things.
I was born in a time when antibiotics actually worked. And that was, this really brief window of time from around the 1940s until around the 1980s. It really seemed like medicine had conquered infectious disease. I mean, it was Sir Alexander Fleming who said this when he got the Nobel Prize. He said that if we use these antibiotics in ways that are not medically necessary, we will provoke the emergence of these drug-resistant strains of bacteria and other pathogens. We already are starting to run out of drugs that are strong enough, and we now have 23,000 Americans dying of drug-resistant bacterial infections every year.
Penicillin, actinomycin, streptomycin, all of these drugs that we have today came from scientists studying soil. But that resource, after so many years of intense study, just began to diminish. And so we realized that the same microorganisms that were in the soil that generated the antibiotics are out there, but they're different. One of my workers was moving up and down the coast, and I said, why don't you stop and just take some beach sand? We discovered the bacterium that makes anthracomycin. We discovered that it was very active against MRSA. And so we began to study this microbe and finally pulled a compound from the complex mixture. This is 1 liter of seawater with nutrients that we know are useful in growing bacteria. We discovered chemically a brand new kind of structure, not related to any other kinds of antibiotics ever discovered, and very potent. We called it anthracomycin. We did the experiment, a model where you inject rats with MRSA, methicillin-resistant staph. They're only going to live for 5 or 6 days. And then you have a treatment group treated with anthracomycin in a way that is similar or identical to how you would treat a human. And then we watched. 85% of the animals survived. They didn't show any evidence of toxicity, a critical piece of information that allows you to convince people that this could, in effect, be a drug. And so the question then became, how can we develop it?
Very few drug companies want to create antibiotics. It's a lot of money to do the R&D. What do you get out of that? You get a drug that's used for maybe a week at most, and which, even though it saves lives, people don't want to pay more than $100 or so. You know, we'll pay tens of thousands of dollars for a cancer treatment that might not even extend life at all. Now, what that means is if that kind of infection is out in the environment, is really an end to medicine as we know it.
Drug-resistant bacteria are one of the most serious public health issues that we face today.
Despite President Obama declaring an initiative to begin to work on this horrible problem, Congress has not allocated funds to do so. As of today, there is no national focus on the development of new antibiotics. When you're looking at such a massive resource out here, you have to remember that finding just those perfect discoveries that are going to cure infectious disease takes time, takes investment, and there's risk. You know, a typical drug for cancer in a pharmaceutical industry would require the involvement of over 200 people, 300, 500 million, $1 billion. The kinds of grant money that I can get are $100,000 per year. We found 6 or 7 good quality antibiotics in the last 6 to 8 years. 5 cancer drugs, 2 of which are currently in clinical trials in humans. The major pharmaceutical industry quit isolating new antibiotic compounds. They quit working with microorganisms. What an error in judgment in my mind, not to think about 75, 80% of the surface of the earth. What's the alternative? Don't develop anything, don't discover anything new, not consider infectious diseases the massive epidemic that it is going to be. 70, 80, 90,000 people dying in the US per year. Our antibiotics that we have are now becoming useless in treating infectious diseases. But should I quit? Should I not keep trying to do so? I don't think so.